So you're in a technical interview, and you get the question. How would you deploy a modern, scalable application? Let's really get into this. Today, we're breaking down that essential toolkit. Everything from a single container all the way up to a fully automated cloud deployment. Think of this as your practical guide to absolutely nailing that conversation.
You know, it always starts out so simple, doesn't it? You build an app, you pop it into a Docker container, and boom, it just works. But then, you get successful. Your traffic starts to climb. And suddenly, you need way more containers, maybe for different microservices. And all at once, trying to manage that by hand becomes a total nightmare. This is the core problem every single successful app runs into.
And the answer to all that complexity? Well, it's a concept called orchestration. This is really the first and most fundamental idea we have to get our heads around when we talk about running applications at any real scale. To put it simply, container orchestration is basically the brain that manages your entire fleet of containers. It's the thing that handles scheduling them onto servers, managing how they talk to each other, scaling them up or down, and even healing them if one of them fails. It is the automation that lets you sleep at night for sure.
So, once you decide you need an orchestrator, you pretty much immediately run into two huge names. Docker Swarm, which is built right into Docker itself, and of course, Kubernetes, the open source giant. And this right here brings us to the first major decision any engineering team is going to have to make.
So let's break this choice down. Seriously, understanding the key differences between Swarm and Kubernetes is absolutely critical for any modern DevOps or SRE role.
And this table just lays out the trade-offs perfectly. On one hand, you have Docker Swarm, which is just beautifully simple. It's already part of Docker, and you can get a cluster up and running with just a couple of commands. It's really perfect for smaller applications or maybe some internal tools. But then you have Kubernetes. It's a powerhouse. It's definitely more complex to set up, but in return, it gives you these incredibly advanced features for things like networking, storage, and automatic self-healing. And those are the things that are absolutely essential for large, complex production systems.
And this brings us to a really crucial piece of interview advice straight from the source material. In today's world, Kubernetes has pretty much become the undisputed king of production workloads. Now, Swarm is a great tool, don't get me wrong, but claiming you use it for a major production app, yeah, that might raise a few eyebrows. So here's the key takeaway, the pro tip for that interview. The strongest answer you can give is that your developers use Docker locally on their machines to build and test. That keeps everything consistent. But the second that code gets pushed, every other environment, dev, test, and of course production, it all runs on Kubernetes. This shows you get the distinct role and the real power of each tool.
Okay, so you've made the smart choice. You've picked Kubernetes. But remember that complexity we talked about? Managing a Kubernetes cluster yourself, the control plane, all the upgrades, the security, that's a full-time job. So how can a team actually focus on building their application without getting completely bogged down in managing infrastructure?
The answer, as it so often is the cloud. By using a managed Kubernetes service, you get to offload all of that heavy lifting. Let's take a look at how this works in AWS, specifically with their Elastic Kubernetes Service, or EKS.
Right, so the main benefit of something like EKS is that AWS manages the entire Kubernetes control plane for you. That's the whole brain of the cluster. They take care of the availability, the patching, the scaling of the master nodes, and that frees you up to just focus on your applications on the worker nodes.
And these managed services solve real-world problems with some super powerful add-ons. For instance, the VPC CNI gives your pods real IP addresses in your network, which makes networking so much simpler. The EBS CSI driver lets your apps use AWS's persistent block storage. And the pod identity agent, well, that one solves a huge security challenge by giving your apps secure access to other AWS services.
Let's actually zoom in on that last one because it's a really common and super important task. Just imagine your application. It's running in a pod and it needs to read a file from an S3 bucket. How do you give it permission to do that, and only that, without hard-coding secret keys right into your container?
This is exactly where that pod identity agent comes in. And the process is actually pretty straightforward. First, you just make sure the agent is running on your cluster. Then, over in AWS, you create a standard IAM role with a policy that grants, say, S3 read access. Now, the magic happens in the EKS console. You create an association that maps that IAM role to a specific Kubernetes service account in a specific namespace. And just like that, any pod that uses that service account automatically gets those S3 permissions. It's secure, and there are no static credentials anywhere. So our infrastructure is solid, right? We've got a managed Kubernetes cluster, it's ready to go, but how do we actually get our code from a developer's laptop to running on that cluster? I mean, manually building images and running kubectl apply, that is not scalable, and it's definitely not safe. We need automation.
And this is where a CI/CD platform, like Azure DevOps, slots in perfectly. It is the final piece of our puzzle. It's the thing that's going to automate our entire software delivery pipeline, from the moment code is committed all the way to a production deployment.
Okay, let's tackle another one of those classic interview questions. Your pipeline is going to need secrets. Database passwords, API keys, all that stuff. And storing them in plain text in your code is a massive, massive security risk. So how do you manage and version control them securely?
This slide shows the critical difference between the easy way and the right way. I mean, you could just store secrets as pipeline variables in Azure DevOps, but they aren't version controlled, and anyone with access can change them. The best practice, and this is the answer you want to give, is to integrate with a dedicated secrets manager, something like Azure Key Vault. This keeps the secrets stored externally in a highly secure, audited, and version-controlled vault.
And the way you do this in Azure DevOps is with something called a variable group. You can create a group that, instead of holding the variables itself, just links directly to your Azure Key Vault. Then, the pipeline securely pulls those secrets from the vault at runtime, making them available to your deployment without ever exposing them in your pipeline's code. It's pretty slick.
Azure DevOps also has some really powerful features for modern app architectures. For example, if you're using a monorepo that has a bunch of different services, you can use path triggers. What this means is that a code change in one service only triggers the build for that specific service. That saves a ton of time and resources. On top of that, it really encourages reusability. You can define all your deployment logic in YAML templates and then reuse that exact same template for all your environments, which guarantees that the way you deploy to dev is identical to how you deploy to prod.
Okay, let's zoom out for a second and put all of these pieces together. Let's look at the complete picture of what a modern deployment toolkit really looks like. And here it is. You can see the entire flow all working together. It all starts with Docker, which packages up the application. Then Kubernetes orchestrates all those containers at scale. AWS EKS gives us that managed environment to run Kubernetes without the operational headache. And finally, Azure DevOps automates the whole CI/CD pipeline, taking code from a developer and delivering it straight to the cluster.
So the most important point here is that none of these tools lives in a vacuum. They are all designed to work together, each one solving a very specific piece of the software delivery puzzle. And together they form this incredibly powerful, integrated system for building, deploying, and running modern apps, reliably and at scale.
And that brings us to our final question. Having this powerful toolkit is the first big step. The next one is mastering it. Now that you can deploy your system, how are you going to start measuring its performance? How will you define its service-level objectives and proactively improve its reliability? That, my friends, is the world of site reliability engineering, and a fantastic topic for another time. Thanks for listening.